Hi, in this video, we are going to see how we can load and performance test our machine learning model. In the last video, I gave an overview on why we need to load and performance test our model and also what are the different metrics we'll be capturing. It's a detailed video. In case if you want to watch it, you can click the link on the top and watch it, or the link to the video is in the description of this video as well. You can go and look and watch it, but it's not mandatory for this video. I'll just give a quick gist of it. So what we said is like this: what we'll be doing in a load and performance testing of our model. Basically, we have our model pipeline over here. We have typically a data collection, preparation, feature engineering, or we may be accessing some database. There are multiple things we'll be doing within a particular model. And what we'll be doing is, like, in order to see like how our model is performing, we'll be simulating some users. We'll be sending user requests, like maybe 1 user per second, 5 users per second, or 50, 500 users per second, or even 1,000 users per second. And we will see basically how a single system is capable of handling the volume, and accordingly we will go and size for equivalent number of systems that is required to deploy the model so that we can meet our business SLA on time. Right, so we need to make sure we need to have a kind of SLA. Say I want the end-to-end model, end-to-end instance to be scored within 30 millisecond or 100 millisecond, depending on your business need. And also, what is the availability requirement? When I say availability, do you want your model to be 100% available? That means all the request has to be kind of scored and sent back, or is it fine if the model is 95% available or 90% available or 80% available? Remember, the more higher the availability is, the higher the infrastructure cost also boils down to. Okay, so that's what we did. And the other aspect you mentioned is like the bottleneck is not only about getting the data and scoring. That can be bottleneck at multiple layers of the model. That can be a network bottleneck, that can be a memory bottleneck, that can be a CPU starvation, there can be some background process running if it's a shared system. So there are a lot of factors that come into play. Okay, so that's what we have been talking about. So now what we are going to do is we are going to like simulate these users and see like how much a one instance of a particular model that is deployed is handling. And then we are going to also go and see like what if I scale that particular model, how many users per or transactions per second the model is able to handle. And when the model, you're training the model, basically it's experimentation process, but after the model is deployed, it is pretty similar to a software engineer project, right? It's almost similar what you'll be doing for your typical any programming language or project or something like that. It's very much applicable to what you'll be doing with your ML models as well, right? So let's get started. So in this case, what I have is I have a Flask application, and this Flask application is nothing but it takes an XGBoost model. It also has a pickle file. It takes a text data, it tokenizes the text data, and finally it scores the particular incoming data between 5 classes. It's a multi-class text classifier, and I'm not going to go into the details of this particular model. If you want the details on the model, also I'll put it in my video description below. You can go and watch it. I have created separate video for training the model and deploying the model. I will put it in the link. You can go and watch it. But this is the application we have. It can be any application. It can be any of your Flask application or the Django application or any application that you have that can be there. So what I'm going to do is I'm going to quickly run this particular Flask application. I am not going to use GUnicorn. I'm just going to run it as a standalone Flask application for us to do the performance test. So let me, the file name is complaints.flask.py. So let me quickly run this one and start the Flask application. Right now, once it completes, this particular Flask application will start, and then the next part I'm going to do is I'm going to start my load testing program. So this is my load test.py, and the package that I'm using to load test is called LOCUST. Now, LOCUST is nothing but it's an open source package, and you just have to do a pip install LOCUST, and you will have LOCUST with you. And it's a pretty simple code. Now, since I have deployed the model, what I will do is I will just quickly go to a different Cloud Shell and I will execute this one. So let me paste what I have. So I'm just doing a curl localhost 5000. If you see, my Flask app has started in localhost 5000. I'm just giving a localhost 5000, passing a text data over here. and then it is returning me a response. It is telling basically this particular text data belongs to students loan category, and the kind of integer value that it is predicting, it's predicting 4. Okay, so this is how it looks like, right? Let me quickly clear it off. So now what I'm going to do is I'm going to write a program that will call this, and we can simulate users as well. Now what I'm doing, if I am first importing like locust, and I'm telling import htt user task and between is just used. If you want, you can use it or you can ignore it, right? And I'm importing JSON, and I'm creating a class, and this class takes http user as an input. All right. So the very first thing is I have an wait time defined. That's why the between is used. I'm telling like each user request that comes in, try to wait between 1 minute and 2 minutes. If you don't want to simulate wait, you can just remove it. Or if you want to say like you want users to wait between 1 second to 2 seconds. If you want users to wait between 1 second to 10 seconds, you can put 1 to 10. So this is just like an optional parameter. And then I define task. The task will tell what I want to do with this particular application. So here what I am telling, my input data is nothing but it contains a text and a value. It's kind of a JSON payload. It's a key value. The key is text. If you saw my previous query that I ran, if you see my input is text and value, key and value, the same thing over here. So input is text, because my model looks for the key text in the input object, and it takes that and score it. Then the value is the actual text data, and I'm just setting the header value here. The header value is basically your content type, that is application JSON, and basically it's the accepting application JSON. That's what I'm telling, because I'm passing a JSON data. And then I am calling basically self. The self is like the object itself, and then I'm telling like client.post, right? And I'm telling call the slash core method. Now if you see in my Flask app, I have the slash score method here, which I need to call to get the score. So I'm just calling this particular slash score method. Okay, that's what I'm doing over here. And I'm telling pass the JSON object, which I have over here payload, and pass the header, which is application.json. And I don't need the response because I'm doing a load testing. I'm not going to do anything with the response. So I don't need the response. That's it. I have my class defined that will allow me to load test. Now what I will do is I will keep continuously passing multiple user parameters to it. Based on that, this class will create multiple parallel objects and call my API. And I will show you like how I can do that. Right now you can have multiple tasks. If you want to like run task 1, you can have add task 1, task 2, task 3, and each can have different methods. So if your API has multiple endpoint, or at the same time you want to test multiple different Flask application that is running, you can do that as well. Right, so that's what this particular package is. Now to run this package, what I can do is I can just call LOCUST, that is the install I have done, -f, and then basically what I'm doing is I'm giving the Python file name load test.py, and once I run it over here, it's going to start it, and it's telling it has started here. If you see over here, it's telling it started 000:8089. Now this spins up a web application, right? So what I can go is I can go back and I can go to 8089 and see the web page. So let me do this. So this is how my web page look like. And let me go back. Here is the Flask application. Now what I can do is I can give basically how many users I want to simulate. That is the first parameter. So I can tell like basically I want to simulate initially for 10 users, and how many users per second I want to span. So I can say like I want to span 2 users per second. I want to start with a lower number, and slowly we will increase it and see how it performs, right? And then I'm giving the host where my application is running, right? So here over here you see I didn't hard code the URL. I just gave slash core. So I can run it on either localhost, or I can run it on any serverless platform or anywhere. So that I can provide over here. So here what I'm doing is I'm telling http:/localhost:5000. Okay, once I give that, I can say like start swarming. So what it will happen is it will continuously keep on sending requests. You can see over here it has started sending requests, and let me go back to my Cloud Shell, and you can see my application has started getting requests, right? So basically what it is, it has sent around 60 requests. There are 10 users. There's 5 requests per second. So if your application needs to handle like 100 requests per second or 100 transactions per second, you need to make sure you need to simulate for that many users and test it. But here, let's start with the simple one. Till now, it has sent around 195 requests, and the average response time from the application is 12 millisecond. The minimum is 8 millisecond and maximum is 52 millisecond. That's what it says, right? And the 90th percentile is 18 millisecond. So if your business SLA is say like 90% availability, then all the requests will be scored by 18 millisecond. But I will show you details. As it goes to higher number, you may have higher latency as well. So let me stop this run. So this gives you a good indication of how your application is performing with 10 users that is running, and basically it's generating around 6.5 requests per second. Now you can go to chart over here, and this chart will show you basically it's around like 6.5 requests per second. There are no failures. And then you have response time. In the response time, you can see basically most of my median response time is 11 or 12 millisecond, but the 95th percentile is around 23 millisecond or 19 millisecond, depending on how it is. So basically, if my SLA, I have to score each transaction within like 25 millisecond, then my system will be easily 95% available. That's what it shows. Initially, there's a spike. That's because it has just got started and the users are just spawning up. That's why it's a spike. Let me go and increase it to basically like 100 users, and then let me do something like 10 users per spawn per second, and let me start running it. So let me go back to the statistics as well while it is getting built. So this starting to getting this basically getting built. Let me go to the console. It's running over here, and I'm not sure why it is refreshing. Just give me a minute. Okay, let me just refresh this way. Okay, now it's running. It did not refresh the page. So now you can see basically it's running around 2024, and the request per second is around like 65.6 requests per second. So now we have increased from 10 times more, from 6 requests around 66 requests per second. And this is how it looks like. And you can see the average response time has slightly increased. The 90th percentile also slightly increased. So you can see basically there's an increase in number. I can again stop it. Let me quickly go to the chart, and you can basically see in the chart this is how it looks like. My median response time is 18 millisecond now, and the basically the 95th percentile is 47 millisecond now. So basically, if you go by the previous number, if I need 25 millisecond response time for 95% availability, then basically my system is not able to scale up for that. So I need to go and parallelize my deployment and run it in basically multiple systems so that I can do a round robin on that. But let me go with this, and let me finally show you one more thing before we go on to multiple deployment. Let me increase this one let me kind of quickly close it, and then let me do a new test, and let me do like 300 users and around 50 users spanned every second, and then localhost 5000. And let me start sending the request, and you can see basically now it has started sending for 300 users spanning 50 users per second, right? And you can see now the request per second is moving up to 124, 137, and even higher, right? And at the same time, if you see the average millisecond has shot up pretty high. The reason is, one is we are using Flask. We are not using GUnicorn. Flask is an basically, it's if you run Flask by default, the internal WSGI server is not production ready. It can take only one request at a time. And second, this we are running only in one system. And now you see basically if you want this system to handle 300 users concurrently, the system is not ready to handle if your SLA is less than 100 millisecond. In this case, it's going above 300 millisecond. Let me quickly stop it. and you can see basically the maximum request per second that has come is 151 requests per second, right? I can go to chart again, and you can see in the chart basically how from the bottom in the previous run, for around like 100 requests per 100 users we ran, for 300 users it has shot up pretty high, and the 95th percentile is 410 millisecond, which might be way higher for some application. For some application it's fine, it depends on the application as well. Now said that, what I'm going to do is I'm going to go and run this in an system where I have deployed it on multiple nodes and see how it is performing. So for that purpose, I am using a App Engine. Now a App Engine is basically kind of a serverless deployment. It is not exactly serverless, but it's kind of like AWS Lambda or other application where I can deploy my where I can kind of deploy my application in the remote, and they will scale up for me. That's what I am going to do. So basically, if you see the services, I have one service running. I have this particular model running and two instance, right? And let me go into the details of this particular instance one. You have two instances up and running, but the way this particular task is deployed is basically it can scale up to 20 nodes. Let me kind of show you that. If you go here and view the configuration, basically here the minimum instance is 2, so it's running 2 instance. Now there is no request coming in, but maximum it can go up to 20 instance. So I have created in such a way that it can go up to 20 instance. So I want to see, based on my request, how it is scaling. That's what my purpose is. So now you have seen basically it is 2 instance. Let me go to dashboard. Let me copy the URL. This is the URL that we will be using to publish. Let me quickly check if the app is up. So this is how the app is. Let me copy the URL. So what I've given in my Flask app is when somebody calls the root URL, I'm just telling, like, just printing a value called welcome to complaints prediction application. And that's why when I clicked on that, you are seeing the text, right? So let me go here, and then let me go back and start a new test. This new test I'm going to run for same 350, but this time I'm going to give this particular URL. It's running in 80, so I don't have to give :5000. I'm giving this URL, and let me start sending the message to my App Engine application. Now it is not running local, it has started. Now let me go to this particular URL, and you can see like it has started. Now earlier you saw around 400-500 millisecond. Now what you are seeing is basically 73 average millisecond is the time. If you go to my App Engine application and go to instances and basically refresh this particular screen, let me see if it has scaled up or not, or it is able to handle in the 2 nodes. Now basically you can see it's still in the node 2 nodes. Let me go back. It's still in the 2 instances. So here I have pushed around like 6,000 messages. Let me stop at this point, and you can see the average response time is around 192 millisecond, and the 90th percentile is 560. I can again go to the chart and quickly see how the chart looks like, and you can see basically this is the response time. You have the mean response time is still low, around 98 millisecond. There have been like, but the 95th percentile is pretty high, right? So initially it was slow, but it became very high. So basically my App Engine has not scaled yet, right? Let me go to instances and let's see if it was scaled or not. It has to auto scale typically based on that, but it takes time. Like when you are running on a serverless engine, it will not scale immediately. It will keep monitoring the volume and then it will scale it. So now the maximum number of systems it took is around, it scaled to 4 from 2. So earlier it was 2, now it's scaled to 4 instances. You go to your versions and you can see basically, just a minute, it's running slow. Yeah, let me refresh this page. It does not take the page until I refresh it. So it has scaled to, for some reason, it has scaled back down to 2 instance now from 4. I see 4, but it's not refreshed in this page. Maybe there is some issue with the Google Cloud Console, but it has scaled to 4 systems, and you can basically see over here this is how it performed. While the median response time was good, but not the 95th percentile. You can also go and check the detailed, but any failures will be here, exceptions will be here. You can go and download the data as well. Basically, you have all the data over here to go and compare. You'll get a CSV file. You can basically download it and compare and see how your basically particular deployed model is performing for multiple users that you are given. You can similarly increase it to 1,000 users or 2,000 users depending on your SLA, and keep sending requests and then monitor the performance. You need to make sure you take into consideration the average millisecond time, the 95th percentile or 99th percentile. The 99th percentile will be in the Excel that you can download, and see whether your business availability need is met, your model performance need is met. So these are the two parameters that you will check. Apart from that, this is not the only thing. You will also go and monitor your system performance, because if your system is not able to handle so many requests because some other process is occupying it, then also it can be a problem. Or there can be a network latency as well. Maybe your model is executing within 5 milliseconds, but the network is taking around 100 milliseconds to reach there. So there are a lot of parameters you need to go and check, but this is a good starting point to start with your performance tests. That's about it. Thank you very much.